Welcome. Today I am going to present microstrip line simulation in ADS, Advanced Design Studio, Agilent. So actually in microstrip line you may consider as an ideal transmission line or ideal two-wire transmission line equivalent. So in ADS we will simulate it and we will see how it is easy in simulating ADS full wave simulation, and that is momentum. First we will simulate ADS schematic, then we will verify with using substrate, and then momentum full wave simulation. So here I am going to generate a schematic file. So first in schematic file you have to select the transmission line, that is T line ideal I have selected, then I have to select T line, that is transmission line. Then after this transmission line, for checking purpose I may use as a 50 ohm transmission line. Then I have to give a port actually. So for port I have to select simulation as parameter, then this icon I have to select termination, 50 ohm termination. This only I can change also if it is not 50 ohm, then the case is different. Then I am giving grounding. Then I have to give simulation setup. So simulation setup is the so-called S parameter. S parameter I have to select start, stop and number of frequency point. So you may give step size also. And sweep type is linear sweep, means linear frequency sweep. Then there are several parameter I can calculate it as parameter, group delay and different noise also. For this transmission line the noise is very less, so no need of noise these things. So I am going to simulate it. So for this case next recheck it, transmission line is 50 ohm and electrical lead, let's say 45 degree at mid frequency 1 to 10 gigahertz, 4.5 gigahertz. Then we will take the simulation procedure in ideal case, which is very exactly to in a theoretical approach. So first I have to save the setup, let's say the name is microstrip, then I have to go to a simulation icon. Then simulation is completed. It is very fast simulation, actually it is ideal condition, it is very matched with theoretical condition. S parameter S11 S21. So ideally I have seen S11 is below 300 dB and S11 is nearly 0 dB. Now I am going to plot phase part of S21. So phase part is you can see at 4.5 degree 4.5 gigahertz, so it is seems 45 degree. So that is I have taken the transmission line length is 45 degree at 4.5 gigahertz. Now I have to plot a group delay. So group delay it is coming 27.7. So we have to actually calculate it in theoretical it is coming correctly or not. So ideally group delay variation is very less. See 27.67 then 8. So it is very less deterioration in group delay, and plotted group delay is picosecond. That's why I am multiplying 10 to the power 12. Now I have to do one thing. This is actual circuit model. Then I have to give the transmission line model in microstrip form. Actually in fabrication and full wave simulation I have to plot in I have to choose a substrate. So for substrate several I have to first select substrate, one transmission line in microstrip substrate domain. Then I have to select microstrip substrate. Let's clarify or just give the some properties on microstrip substrate. Let's say this substrate may be RTD at 4003C. The loss tangent is 0.0027, very less lossy substrate. You can use a very low cost FR4 substrate in this content also. The substrate I have chosen 0.508 mm thickness, dielectric thickness, and dielectric constant 3.55, and thickness copper cladding thickness is very less 17 micrometer, and roughness all the initial parameter let's say as default. Then transmission line I have chosen, then I have to give the transmission line equivalent line width and thickness, all the things. So for this case I have to actually take the help of line calculator inbuilt in ADS. The epsilon r, all the values I have inputted here. So as per dielectric actually Rogers Corporation data sheet, I have to see the, you may see the Rogers 4003C data sheet on internet. So as per the data sheet I have given all the parameters here, and then I have to calculate actually for 50 ohm line and effective 45 degree transmission length here 4.5 degree, sorry, 4.5 gigahertz frequency. Then I have to calculate W, equivalent width of the transmission line and length of the transmission line. Then that is obtain 1.1 on mm and 4. Substrate 1.1 on mm and let's say see 4.9978. So I have to put the thing 4.9878. You may give 4.99, that's all, or 5 mm, nothing will be happened. Then I have to again reterminate port 1, port 3 and 4. Here I am giving actually different ports, so I can tally the result. Earlier result, that is earlier result may be the theoretical, it is equivalent to theoretical model. So you can see, so two result I have shown, earlier existing result and using substrate what is the effect. So S33 and S43. See, there are so many deterioration is coming, so it is little not distinguishable here. So let's do one thing, replot it, just delete the earlier S1, then using substrate I have to plot. So it is coming below 40 dB over the frequency band 1 to 10 gigahertz, and S43, that is insertion losses less than very near to 0. Then so this is actually using substrate. Then another thing, before fabrication you have to first next confirm it the full wave simulation, that is momentum simulation. Here I am going to plot another group delay also. You may see the group delay, it may vary, just plus minus 0.5 picosecond like that. This should be happened because this type of transmission line, some fringing field, all of things will be there. Let's see, let's go for momentum simulation. For that, just I am giving disable this part. So in momentum, actually I will do this model. Actually I have to import it. So first go general layout. So automatically it will take the layout whatever I am giving. So this transmission line is coming. Wall width length as usual it is schematic. Whatever use I have in schematic. Now I am giving port here. Then I have to give define substrate. So which substrate I have used in schematic, momentum has to same. So update from schematic I have to use. So all substrate parameter will coming here. So it is very easier. Now I have to check it. Yes, it is coming 0.508 thickness and substrate layer 3.55 dielectric. All the parameters is here coming. So now I can set up the simulation setup. So it is obviously local machine, and then simulation is parameter. Again I have to actually set the parameter 1 to 10 gigahertz and all the parameters as earlier. I am giving less point, so that it will take lower simulation time. So it is showing some error, means substrate parameter. So just yes, ignore it. Then simulation started, and it's take little time, but ADS, as the transmission line length is very small, so it will take lesser time. So in this case microstrip transmission line is very easier part for understanding. So at the meantime microstrip transmission line, it is a very low power transmission line, so you can't use high power transmission. So momentum simulation is over, that's fine. See, S1 on, that is insertion is very less. So next what we have to do, we will compare all three results. Just when there is no substrate, when substrate I have added, and after full wave simulation. So actually I will see what is the difference between three simulation, and actually we have to depend on fabrication when I have used the full wave simulation. So for full wave simulation you have to take a layout component, then you have to export the layout component in schematic window. So for this case maybe schematic file name same and layout file name same, that's why I have to save as, that is a common practice in ADS. So let's say it is exam giving layout microstrip part here, then momentum component create, so I am giving a component, layout component successfully created. Then next go to schematic, open the schematic file, then I have to go component library, actually this is display component library list, then test layout component, it is available, then I have to put it here. Then similarly the similar fashion I will do, give port 5, 6, then I will do check the all the simulation parameter, how it is different from the schematic model. So microstrip simulation is very easier simulation. So for that next case, next part, I can show you different, at least complex structure, maybe filter or antenna. So this is the basic steps you can follow, and you can utilize your project or your education system in educational purpose, this type of simulation where theory, it will match with theoretical using and fabrication, so you can easily compare your result. So I am giving after the component you have to actually, this is actually this figure, it is not coming after simulation. So simulation is running, it will take time. So in this window you will show three type of result we will show. So simulation completed. So let's see how was the result. Then next plot it, S parameter S55 and S65. Yes, it is below 40 dB after full wave simulation. So it is from my experience. So minus 40 dB you can get in measurement for sensitive VNA. You can at least get minus 30 dB or 35 dB S1 on, and loss is as close as 0. And microstrip fabrication also you have to use several calibration technique, so to obtain how accurate your fabrication with simulation. So this type of calibration we may discuss another day, so which will give perfect simulation and fabrication result. So this graph I am showing ideal case, that may be theoretical and using substrate and full wave simulation. So you see this right side graph, full wave simulation means momentum simulation and using substrate parameter, that is nearly close, all are below 40 dB. So it is give good perfect impedance. Also if I change the transmission line 50 ohm, let's say 60 ohm, then reflection coefficient may be varied. So you may try for this impedance mismatching effect. So for this case I am going to finish it. Scattering parameter, very easy. Microstrip simulation. Already previous episode I am trying to simulate microstrip transmission line in HFSS. Now I am going to try it with ADS. ADS is very suitable, not very maybe in terms of simplified. You can simply connect active component as well. So active component integration, it may be the highest opportunity nowadays to design anything. Also in layout you can change the substrate as you wish. You can modify it here also. You can modify width of the substrate and length of the substrate or different angle or different things. So for this case you may not go to schematic, and you can first not need to generate it again. So it will save time actually. Also several things, gap scenario you can use in this window. Thank you for watching